Welcome to our mathematics class again. We've talked about indices of numbers, likewise indicial equation. So we're going to be looking at another topic. So that will be common logarithm. Have you heard about common logarithm before? What can you say about common logarithm? Today we are going to throw some light into the topic. This is Mr. Salam. Get your writing materials, get your logarithm tables and your anti-logarithm tables. So in other words, if you have a 4-figure table, you should get it ready as we'll be looking at this together. So let's continue. The common logarithm at the end of this topic, we should be able to look at the following aspects of the topic. Number one, you should be able to explain the meaning of logarithm. Number two, you should be able to determine the logarithm of numbers using the logarithm tables. Number three, you should be able to determine the anti-logarithm of numbers using the anti-logarithm tables. Now, what do you know about logarithms? Logarithms were actually developed to simplify complex arithmetic calculations. So they were designed to transform multiplicative process into additive ones. What do I mean by that? For example, let's find the product of these two numbers. 34,459 and 56,234 without using a calculator. Okay, of course, it is a lot not easier to carry out the product of these two numbers. So what do we do? Without a calculator, you cannot multiply these two numbers. It will be very difficult for you. So, logarithm has come to help you simplify this number very well. So, our first question then must be, what is a logarithm? Now, what is a logarithm? The common or base 10 logarithm of a number is the power to which 10 must be raised to give the number. So the common logarithm can also be called base 10 logarithm. So we're still going to be looking at another aspect of logarithm. So let's focus on the common logarithm or base 10 logarithm first. Now let's look at 100. Since 100 can be written as 10 raised to the power 2, then the logarithm of 100 is equal to 2. So this is written as log 100 equals 2. So likewise, 1 million can be written as 10 raised to the power 6. So the logarithm of 1 million is 6. Now, what about the logarithm of small numbers? For example, we have 0.0001. This can be written as 10 raised to the power minus 4. So, log 0.0001 is minus 4. All numbers less than 1 have negative logarithms. So you should take note of that. So as the numbers get smaller and smaller, so their logs approach negative infinity. Now, logarithm is not actually defined for negative numbers. So let's look at logarithms of numbers that are not exactly of power of 10. So numbers not exact powers of 10. So since I told you earlier on that logarithms are defined for all positive numbers, now since logarithm of 100 is 2 and log of 1000 is 3, so let's find the logarithm of 500. So it follows that the logarithm of the 500 must be between 2 and 3, that is 2 point something. So if you check your logarithm table very well, so you realize that the logarithm of 500, that is logarithm of 50 under 0, will be 0.699, and so on like that. Or you just press a calculator, you have your answer. Now the logarithm of a number consists of two parts called the characteristics and the mantissa. So the characteristics is actually a whole number, while the mantissa is the decimal part of the logarithm. So look at this example. If the logarithm of a number is 2.1782, so the number before the point, which is the whole number, is the characteristics, and the digits after the decimal point, which is 1782, is called the mantissa. Now let's see how we can actually determine the characteristics of a logarithm. So to get the characteristics of a number, first we can express the number in standard form. Then the power of 10 becomes the characteristics of the number. For example, let's look at this. So let's quickly draw our table first. So we have the numbers in standard form, the logarithms, which can be divided into two parts, characteristics and mantissa, then the final answer. So let's look at this for example. Let's look at 5 for example. Five can be written in standard form as 5.0 times 10 raised to the power 0. So the characteristics would be the power of 10, which is 0. And how do you find the mantissa? You can find that using the logarithm table. We are going to talk about that later. So that will be 0.6990. That is the logarithm of 50 under 0. So the final answer will be 0.6990. So let's look at this for another one. 69.24. So how do we find the characteristics? So let's express 69.24 in standard form. So that will give us 6.924 times 10 raised to the power 1. So 1 is the characteristics. So we'll find the mantissa. We're still going to talk about how to find the mantissa later. So our final answer will be 1.8403. So look at this, 0.0843. So in standard form it becomes 8.43 times 10 raised to the power minus 2. So the characteristics would be the power of 10, which is minus 2, or bar 2. minus 2 or about 2. So the multiplier will be the logarithm of 84 under 3. So that will be 0.9258. So the final answer will be bar 2.9258. This is called bar 2. B-A-R, bar. Another way to find the characteristics is this. First, look at the whole number here. Look at the number. How many digits does the whole number have? This one has just one digit. So you say the 1 minus 1, invisible 1. So that will be 0. So the characteristic becomes 0. Look at this. The whole number here is 69. So which has 2 digits. So that will be 2 minus 1, which is 1. If the whole number has 3 digits, so the characteristic will be 3 minus 1, and so on like that. But if the number here begins with 0, just like this, so if the whole number is 0, so it means the characteristics will be bar something. So bar what? Count the number of 0 before the first non-zero digit. So the number of 0 here is 1, 2. So that is why we have bar 2 here. So normally we use this symbol bar 2. So this is how the logarithm table will look like. So this is the number, this is the difference. Now, how do we determine the multiplier? So we need a logarithm table as shown below. So this is the logarithm table, and I'm going to teach you how to find the multiplier using this logarithm table. For example, find log 194.5. Of course, this is the characteristics. So the characteristics will be 2, since we have 3 digits in the whole number here. So that will be 3 minus 1, 2. So, but we're going to focus on how to find the multiplier here. So first, you look at your 4-figure table here. So then locate this 19, the first 2 digits, which is 19, under the next digit, under 4, in your 4-figure table. So look at 19 under 4. So the number is 2878. So I'm going to write it somewhere. So look at it. I'm writing 0.2878. Then since I have another digit here, so it means I'm going to find the difference of the next digit. That is, find the difference of 5. After finding the difference of 5, we are going to add it to this number. So I said, then add the difference of 5 to the number. So look at the difference of 5 here. So this is where you can locate your difference. So the difference 5 is 11. So I will add 11 to this number. So that will give me 0.2889. So therefore, the logarithm of this number will be 2.2889. Don't forget, this is the characteristics. Of course, I've told you how to find your characteristics. So we have 1, 2, 3 digits here. So the 3 minus 1 is 2. So that is how you find the logarithm of a number. So don't forget that. So let's look at some examples here. Find the logarithm of these numbers. Number 1, 6,324. Number 2, 3.24. Number 3, 0.06401. Then number 4, we have 0.0084. So let's look at this. Let's look at the first number here. The first number is, okay, we have the number, the characteristics, the multiplier, and the logarithm. So number 1, we have 6,000 324. So what is the characteristics of this number? Since this is just a whole number and the whole number has 4 digits, so we say 4 minus 1, so the characteristics becomes what? 3. And the mantissa of this number is the logarithm of 63 under 4 difference of under 2 difference of 4. So that will give us 0.8010. So the logarithm of this number will be 3.8010. That's all. So don't forget, if you want to find the logarithm of this number, the mantissa, so you say the logarithm of 63 under 2, the answer you get, you add the difference of 4 to the answer. So that will give us this. Number 2. We have 63.24. The characteristics of this number is 1. How did I get my 1? Since the whole number has just 2 digits, 6 and 3, so you subtract 1 from the 2, that will give us 1. Of course, the mantissa will be the same thing as this, since they have the same number, 63 under 2, difference 4. So that will be 0.8010. So the final logarithm will be 1.8010. Now let's look at number 3. We have 0.06401. Don't forget I told you to find the logarithm of this number. The characteristics of this number will be about 2. Since there are 2 zeros before the first non-zero digit here, so I will have about 2. Then how do I find the mantissa? So you locate the logarithm of 64 under 0, difference of 1. So that will be 0.8062. So the final answer will now be bar 2.8062. Number 4. We have 0.0084. So the characteristics, how many zeros do we have before this 8? We have 3 zeros, that will be bar 3. So the mantissa would be the logarithm of 84. You can see there is no digit here, so we're going to put 0 here. So that will be the logarithm of 84 under 0 would be 9243. So since there is no that digit here, it means there is no difference. So the final answer will be bar 3.9243. So that is it. Now let's look at anti-logarithm. Anti-logarithm. The word anti. So what does it mean? Now, an antilog is the reverse of logarithm. For example, if the logarithm of a number, let's say 1000, is 3, so then the antilogarithm of 3 would be 1000. If the logarithm of a number is 100, its logarithm of 100 is 2, the antilogarithm of 2 will be 100. So the antilog of a number is just the opposite of logarithm of the same number. Now, to determine the antilog of a number, so in an antilog table, so what do we do? So the following should be considered. So let's look at the first one. Number 1. So the mantissa, that is the decimal part of the number, is found using the antilogarithm tables only first. Then consider the characteristics. Don't forget the characteristics is the whole part of the number. So we are going to consider the characteristics to determine where to place the decimal point. So finally, the number of digits for the whole part will therefore be one more than the characteristics of the logarithm. So let's look at these examples here. So find the anti-logarithm of 2.5498. The antilog of 2.5498. So this is an anti-logarithm table here. First, we are going to locate 54. Don't forget, we're only interested in this mantissa here. So we locate 54 under 9. So look at my 54 here, under 9. So that will be 3540. 3540. Then difference the next digit, which is difference 8. So we're going to add the difference of 8 to the number. So that will be 6. So we're going to add 6 to this number here. So that will give us 3546. But that is not our final answer. So let's come back to our characteristics, which is 2. So if you add 1 to this 2, if characteristics is 1, you add 1 to 1. So whatever the characteristics is, you add 1 to it. So since this is 2, you add 1 to 2, that will be 3. So that will tell us where to place our decimal point. Now since we have got 2 and 1 added to it will be 3, so you take it from the back here. So that will be 1, 2, 3. So that's it. So our final answer will be, we're going to take it from the front. So that will be 1, 2, 3. So our final answer will be 354.6. 354.6. So I'll take it at 1, 2, 3. So the final answer will be 354.6. So that's all. So let's look at these examples here. Find the anti-logarithm of these numbers: 3.672, 0.0927, bar 1.6008, bar 3.6008. So what do we do? So let's quickly draw our table. So the first number here is 3.6724. So don't forget the characteristics here is 3. So let's note it. So the anti-logarithm of 67 under 2 difference 4 will give us 4703. So the final answer will be, you move your distance, you add 1 to this 3, your characteristics, that will be 4. So you move your points 4 times from this place, 1, 2, 3, 4. So since there is no number here, so your final anti-logarithm will be 4703. That is 4703. So the logarithm of 4703 will give you this number. So let's look at number 2 here. Number 2 is 0.0927. So don't forget the characteristics here is bar 2. Okay, so the characteristics here is 0, so that is the whole number. So the anti-logarithm of 92 under 7 will give us 1237. So how do we now determine our final answer? Since the characteristics is 0, so we add 1 to this 0 here, so that would be 1. So we now move our points like this to this place. So the final answer will be 1.237. So it means the logarithm of 1.237 will give us 0.0927. Number 3. So the characteristics of number 3 is bar 1. So don't forget the bar 1 is the same thing as -1. So first, let's find the logarithm of antilogarithm of 60 under 0 difference 8. So that will give us 3988. So our final answer will be, since the characteristics is -1 on bar 1, so -1 plus 1 will give us 0. Now, if the answer is, if the characteristics is bar 1, so we are going to add 1 0 before the decimal point, before the first non-zero digit here. So that will be 0 point. If it is bar 2, we add 2 0. If it is bar 3, we add 3 0. So and so on like that. So let's look at this for example. Now, since the characteristics is bar 3, and don't forget 6008 is the same thing as this, so the number will be 3988. So what do? We add 3 zeros to it, so that will be 0.003988. So that is it. Let's assume the characteristics is bar 2, it will be 0.03988. If the characteristics is bar 4, it will be 0.0003988. So if the characteristics is negative, we have 0 point something. Okay, so the number of 0 depends on the number of bar we have here. So now time for exercises. So let's look at these exercises. Number 1, using the logarithm tables, find the logarithm of the followings. Number 1, 6935. Number 2, the logarithm of 0.9876. Number 3, the logarithm of 28.9. And number 4, the logarithm of 0.0065. And number 5, the logarithm of 3.098. So let's look at exercise 2. Using the antilogarithm tables, find the antilog of the following. 2.642, the antilog of 0.982. Number 3, the antilog of bar 2.2876. And number 4, the antilog of bar 3.1806. And number 5, the antilogarithm of 1.6541. So you can go back to the video one more time for proper understanding. Thank you very much for your attention again. So we're going to meet in our next class to look at some worked examples on logarithm. So see you again in our next class. Goodbye.